Hello everyone, welcome back to the second video in the Offensive Security C2 series. In today's video, we're going to be going over the simplest of tools to help assist us with C2 communications. It's going to be sort of a network Swiss Army knife shootout, if you will, between Netcat, Ncat, and Socat to show off what features that they may provide should they be used as a simple means of catching shells for command and control operations. I do want to apologize quickly. I am using my lab today, which means the servers are on and there may be a bit of fan noise in the background. This should be much calmer than the fan noise was in my update video, but I still apologize if there is still fan noise. I've got a mic isolation shield and I'll probably do some editing in post just to filter that out if it is really bad, but otherwise there's not a whole lot I can do about it because we need these lab VMs to conduct the video, so deal with it. But other than that, I'm going to throw up the quick disclaimer segue and we'll dive right into the video. Okay, so in the last video I showed how we could use Netcat to perform very basic C2 operations. Netcat is an awesome tool. You can basically use it to communicate over almost any network protocol by hand, and that comes in handy for things like fuzzing web apps all the way to gaining remote control over a host. When it comes to talking about C2, Netcat may be a good tool to use to demonstrate a proof of concept, but what if we need to stay stealthy? Or what if we need a full session with a TTY and all the amenities that come with that, but there's no way to upgrade on the host side? Or what if Netcat's just not installed at all? Well, that last one isn't as likely, but for the rest, we will address those by going over the features of Netcat's more robust siblings, Ncat and Socat. Before we talk about the shiny new toys though, I still want to go over some of the pros and cons of using Netcat for basic C2 communications. Pro number one is that it's almost always installed on any Nix-based system. So whether it's Mac OS or Unix or any standard Linux distribution, you'll probably find Netcat. And even the BSD variant can be used to gain code execution with some bash foo. This means that if for some reason you can't get your fancy payload to run, but you know you have code execution, you'll likely be able to phone home with Netcat to gain an interactive shell. Point number two is that it's lightweight, it's simple and easy to use. Like we saw in the last video, it's very simple to use Netcat for C2 communications. Whether you need to serve a bind or reverse shell, Netcat can do it with virtually no fuss. And point number three, like the man page says, it is a Swiss Army knife, so to speak. This just means that it's malleable enough to do all kinds of weird things like download files, serve up proxies, and even host a simple web server. You can even catch shells from different operating systems. Pretty much as long as it speaks TCP and even sometimes UDP, you could probably use Netcat for it. However, when we dive into the cons, we see some pretty big weaknesses for using Netcat. The biggest con of Netcat is that it does everything over clear text. This is unencrypted communication, of course. This may not be a big deal for a proof of concept, but it is a huge downside if we're trying to stay under the radar on a penetration testing engagement. Don't believe me? Well, let's run a quick packet analysis with Wireshark as we do some reverse shell stuff. So first I'll set up our little environment here. So we'll have our server on the left side again and our client on the right. So the first client we're going to go to over here is Kanye. So these are the systems in my lab environment. I have them all comically named as famous rappers. I do enjoy rap music. This isn't really to pick on any particular rapper. They're not named for any particular reason or order. I just needed a naming scheme for my lab, for the domain in particular. But both my girlfriend and I thought this was comical. So we went with rappers for the names of the users and host names on many of these boxes. So hopefully you find that hilarious too. If not, well, it's just the naming scheme. That aside though, we are going to start a reverse shell. And as you can see, the Netcat OpenBSD package is actually installed rather than the normal one. This means that we don't have the -E or -C flags that we would normally have to gain code execution with Netcat. And so despite what I said in my last video, I actually am going to show this and link some Pentester cheat sheet stuff that I'll mention later on in the video, just to be helpful and provide some good resources. And even though this isn't really relevant for the C2 series, I think it's nice to throw some little tricks in there every so often. So that just came about as I was writing this new script, so disregard what I said in the last video. We're going to show it in this video. So before we do all that though, we of course need to start up Wireshark, because that was our whole point, is we're going to show how Netcat is insecure and is communicating over clear text. So we'll start a packet capture on our Ethernet interface, which is what I'm using to connect to the lab. And then we will do this simple, I say simple, hold on, having some errors here. Then we will do the simple syntax to do a reverse shell. So we of course want to start our listener on our C2 server. So hopefully you remember the flags from last time. We'll start our listener on port 1337. And then over here we have this big fancy bash one-liner of sorts. So we're going to start off with nc for Netcat, and then call over to our host, which I know is on 2.187. That's where our C2 server lives. And the reason I know this is because I did an ifconfig before that, so I'm hopefully remembering that right off the dome. If not, we'll see very quickly. So Ippsec has a great video where he attempts to break this down. I'm not going to try to butcher this. I feel like he does a much better job than me. I will try to link that video if I can find it when I'm coming up with the description. But basically what you need to understand here is that we're making some kind of file input, file output, file descriptor or named pipe of sorts that we are piping all these commands into, which eventually pipes bin.sh into Netcat, and we're doing all these read writes and using cat to basically hijack a shell using this file descriptor and funneling those communications through Netcat. Like I said, I don't want to butcher it too much. This is just one of the many one-liners that can be found on many of the reverse shell cheat sheets that are out there. And this is how you force the BSD variant of Netcat to actually send over a reverse shell, even though it doesn't have the -e flag. So we're going to go ahead and send over that communication. And as you can see, back on our C2 server, we have a shell. So I'm going to run ID and a couple different commands. And I'm even going to come up with just a quick funny scenario here. I will delete our bash history. So I'm going to remove the bash history, and then I'm going to exit. And now I deleted the bash history. I'm a clever hacker. They'll never know what commands I ran, right? Well, if you remember that packet capture we're running in the background, we'll stop it real quick. And we'll look at all communications that were going on TCP port 1337. And here's the full packet capture of our C2 communications that we were just observing. Now, if we follow this TCP stream, we can now see in clear text all of the commands we just executed on the system. So even though we deleted that bash history, well, here's our bash history right here. So if you're on the blue team and you are actively collecting some kind of packet capture on your network, if somebody's just using raw Netcat for C2 communications, you'll be able to use this as a great forensic tool. It's just fantastic evidence right out of the box. But as the red team, we don't want that to happen. So we'll see some alternatives to how we can establish some more covert communications as we go through the video. Alright, so we'll close out a Wireshark. Now on to the next and final con for Netcat. This one is that it's simple. Now we also mentioned this as a pro, and it is a good thing. But what I mean by this in terms of it being a con is that it just lacks features that Ncat and Socat have. And one big feature related to this con is TLS support, like we just saw. Netcat only does networking, and while you can make it do just about anything, even support TLS somehow, it's going to be far easier just to use Ncat or Socat, as you'll see. It's also going to be much easier to state the features that Ncat and Socat do have comparatively as we continue, rather than to say what Netcat doesn't have, because it honestly doesn't have too much. Alright, so next up in this little simple C2 shootout is Ncat. So we'll pull out our next box. It's Dr. Dre. Now, Ncat is a variant of Netcat that is maintained by the wonderful Nmat project. What's nice about Ncat is that it's fully backwards compatible with Netcat. As you saw in the previous video, when I ran Netcat on my Kali box, or our C2 server, it was actually aliased to Ncat, and it still executed perfectly with the exact same parameters. This is on purpose. Ncat was basically built to be Netcat with some additional features that are much needed in my opinion. So let's start off with the pros first. Point number one is that Ncat has TLS support, and it is so simple to use. All you have to do is simply pass along the SSL flag, and you'll have some nice covert communication channels for your C2 traffic. So let's do that same Wireshark packet capture example again, only this time with encrypted communications. So I'm going to start up Wireshark, start our packet capture, minimize this in the background, and we can see that Ncat is actually installed over here on the Dre host. Alright, so now we'll start our reverse shell listener, Ncat-lvmp on port 1337, and now we'll pass it the --SSL flag. Now what this is going to do is dynamically generate a temporary SSL certificate that we're going to use to encrypt our communications. Now back on our other host where Ncat is installed, we'll type in our IP of our C2 server and the port it's going to communicate on, and also the --SSL. In addition to this, of course, we need to pass the -e flag and send over /bin/bash. If we execute this, we'll get a connection back. We can actually run some stuff. The directory was empty. Okay, cool. Yeah, so that is all of our C2 communication. If we go back to our Wireshark packet capture and hit stop, and then examine on port 1337 again, we can see that we have all of these communications going on. This communication from earlier I actually goofed in the demo in the background. You won't get to see that because that gets edited out. But in all the rest of these, we have our key exchange, and we actually see full TLS communication. So if we do a full TCP stream follow, we can see that there is some Netcat headers. So this is actually a good way to do some detection for those blue teamers out there. Make sure you pay attention to that. This is sent in the clear text. But otherwise, everything we did, it's all encrypted. They can't see what commands we ran. They don't know what it is we did. They only know what our C2 server IP was and the fact that we used Ncat. But everything else is encrypted. Now, there is a downside to this, of course. These SSL certs are dynamically generated and completely untrusted, which means if somebody wanted to man the middle of your connection, especially say the defenders on that particular network that you're targeting, maybe they have like a proxy in place. They can man the middle of traffic from your target to your C2 and serve it a different SSL cert, and then just pass things along with another SSL cert to your C2, and all the traffic is encrypted from you to them and them to your target, but they can see everything in between, right? So we may not want to do that. Now, I've had some trouble getting this to work, but I did want to just demonstrate what you would do to generate your own keys by default and what the syntax would be. I'm not going to execute this though, just because I know it's not going to work out of the box. One of the primary reasons it's not going to work for this particular demo is because on our target box, Dre, we're running Ncat version 7.50, and on my server, we're running Ncat version 7.80, and there's just some SSL conflicts. But I've also had some issues even on the same version of Ncat, and I'm really not sure why. So I'll leave that as some homework for you all to do. If you figure out how to successfully do a trusted SSL cert connection over Ncat, share what you did in the comments. I'd love to know. It helped me work around my errors. Most of the time, this isn't really too relevant for me. I'm able to get along just fine, or I'm using other tools where this isn't applicable. But this is a good trick to know if you're in a pinch and you need to do this. So I'm going to show how to generate the SSL cert first, and then I'm going to show the basic syntax for everything, and then we'll move along. All right, so to generate the OpenSSL cert, we use the OpenSSL command, and we do rec new an x509 cert, and then we're going to generate a key and a test cert. And here it wants a PIM passphrase, so I'll just make just a very simple passphrase, run through all of the defaults for generating a SSL cert, and we'll see now we have a test cert and a test key. Now if we want to start a listener, all I have to do now is specify Ncat, use the -SSL flag, specify the cert and the key that we want to use. And it's going to make us type in our passphrase. And now we're listening on an encrypted SSL connection with a custom cert. Now back on our target machine, we're going to paste in this command. And since we have it here, we'll go ahead and run it just because. But it will fail, and you'll see kind of one of the examples of the error run. This particular error, again, is just because of older Netcat versions, I believe. But what we're doing here is, actually this won't work at all for sure because we forgot one crucial step. So before we can do anything, we actually need to copy over this test cert. So I'm going to hit enter, but then I'm going to stop. And I'm actually going to show just a quick file input redirection trick just because I feel like that'll be helpful. So we will redirect the test.cert with Ncat. So what we're doing is we're taking the contents, redirecting this through our network. So on our listener, we're basically serving the contents of this file now. And then we can connect to our listener. And then what happens is we'll receive the contents of that file, and then we'll redirect that into our output for test.cert. Now normally this doesn't take a long time, and it'll usually cancel out once it's done uploading, but in this case I know it's not going to, and we can just verify the file size real quick of each. So we see test.cert is 1.3K, and if we come over to our test.cert here is also 1.3K. So that file transfer seemed to have gone successfully. So that's just a basic example of how you can do file transfers over Ncat or Netcat or Socat, any of them really, and shows just the versatility of these tools. So we're going to start a listener again. And so now that we've moved the cert file over, you can see that the parameters that we have here are to verify the SSL certificate that's on the other end, and how we're going to do that is tell it what the certificate is. So that way, the only way it can be verified is if it has the certificate with it. So it's kind of like its key, right? So now it's going to be much harder to man in the middle of traffic. We're going to send this over with a bash connection, but you'll see that we get a failed SSL connection, and I believe this is just because of the mismatched SSL libraries, but there is a similar SSL read error I get even between two version 7.8.0s on the exact same host if I just do like a local reverse shell. So that's your homework. Figure that out. Have a good time. But we're going to move on for this video. Another cool feature that Ncat provides is the ability to proxy connections through SOCs or HTTP proxies. And it can even function as a proxy. Now, you can get Netcat to route connections through a proxy as a normal feature. In fact, let's look at the man page for Netcat real quick. So if we scroll down a little bit, I think we scrolled down a little too far, we can actually see that we have proxy protocol, proxy address. So this will help forward along proxies using Netcat, and that's just native. However, if we look at the man page for Ncat, it does a little bit more. So you can do the same type of thing where you proxy connections, but Ncat can also just function as a simple HTTP proxy. It can be the proxy connection. And I've demonstrated this in my pivoting video during the OSCP Journey series, so if you haven't checked that out, it might be a good thing to watch. But basically, it's just a super easy way to pivot your connections, especially through like a Windows systems, because there are readily available Ncat binaries to just drop on Windows systems. And that just helps in general if you need to pivot through a host where you maybe don't have SSH or another means of proxying. It's just another utility that you can use for pivoting. Now, Ncat, of course, has many more features, but those two in particular are the ones that I use the most. I tend to default to Ncat unless I need some specific functionality, as it's fairly easy to get portable binaries for, and it provides some very user-friendly functionality for whatever network shenanigans that I may need to perform. The only notable con I have for Ncat is that it can't serve as a standalone SOCs proxy without some wizardry, which means we're stuck with HTTP. But aside from that, the only cons are what it can't do when compared to Socat. So let's move along. Right, so like I said, the final contender I'll bring into the showdown is Socat. Now, Socat is usually regarded as the most robust of the three tools, and that's fair, as I've done some crazy things with Socat that I've only been able to do with Socat. The downside with Socat, as you will see, is that it's very verbose, which makes it hard to remember clever one-off commands. Now, the two biggest features I've used with Socat are, one, the fact that Socat also supports encrypted connections via SSL, much like Ncat does. Only it's a lot more verbose, and standalone Socat binaries are a lot more difficult to access. More on that in a moment. Alright, so we're going to demo the Socat SSL connections, and we're going to do our Wireshark example just to stay true to our theme here. So we'll start a packet capture. So for Socat, we actually need to generate our own SSL certificate. So we'll do something similar to what we did with Ncat, only this time we just need the PIM file. So we're going to use this command. It's going to generate our PIM file. We'll use all the defaults because we don't really care for this example. And there we go, server.pim. I'm actually going to remove these test certs just to clean stuff up as we go. Alright, so now that we have our PIM file in place, we can actually run this command to start our listener. So we'll replace $port with 1337. And I'll briefly explain what's going on here, but like I said, Socat's just very verbose. So we're specifying a few basic parameters to deal with TTY and basically shell environment variables for our handler. Say, hey, we're doing this with TTY or raw, we're setting echo to 0. And the most important part of this command is actually this OpenSSL-listen. This is going to be the biggest difference between this example and the next example that we'll show with Socat. But we're saying, hey, listen on 1337, reuse your current address. This is just important because it's an SSL connection. Specify the cert, which is going to be our server.pim, and then set verification equal to 0, which means we're not going to verify the cert, which you may already be realizing means that, much like our Ncat example, even though we generate our own cert here, if we're not verifying, this also could be subject to man-in-the-middle attacks. And I believe that to be true, but for the sake of time, we're not going to be going over a SSL verification variant for this particular example. That's actually just homework for you to go do. Go explore and play around with these commands some more, read your man pages, and all that good stuff. You need to go and learn on your own, just like I have. And in fact, it's probably some homework for me to do because I don't know how to do it off the top of my head, and it's not in my notes, which is always going to be my excuse. So anyway, let's start a listener. It's going to start listening. It's not really going to give us any feedback, but it's going to use that server.pim that we had before. And I'm going to now start our reverse shell. So I'll copy this over. And we need to change our IP import here to connect back to the proper C2 server that we have. So it's going to be IP:port. And you'll see here, again, the most important thing that we're doing is this OpenSSL-connect. And this is going to be the biggest difference between a encrypted reverse shell and a non-encrypted reverse shell. The other things that are important to notice are these exec parameters. So these are the things that we're going to execute and send over with Socat. The biggest one, of course, being bash. If we just did bash, it would just send over bash. But we're also sending PTY, standard error, and set SID. So these are some terminal niceties, and we'll actually go over this just a bit more in the next example. So we'll execute this, and then we get a nice encrypted reverse shell. So we'll run a couple commands, and then we'll exit out, and that kills our session. And then we'll go look at our packet capture that we had running in the background, and we'll specify our TCP port 1337, and here is our encrypted TCP stream. And if we follow this stream at any point, I'll just pick this one, we can see that we do have some weird, I believe this is like the SSL cert information is what it looks like. We do have that, but aside from that, the entire communications were encrypted. So we have a nice covert channel to do C2 communications over, and it's not really as easily fingerprinted because all of this information can be changed. So yeah, that's Socat. That's encrypted channels with Socat. There's actually another really nice feature with Socat that we actually just demonstrated, but I'm going to go into more detail in this next point. So Socat can not only be used to send Ncat shells for C2, but if you're actually able to use Socat on both sides, you not only benefit from encrypted connections, but you also get the ability to spawn a fully functioning shell with a TTY, error handling, and all that good stuff. So now you're not limited to what commands you can run. So it's just truly beautiful, and knowing this feature exists in Socat has been the only way I've been able to perform privilege escalation whenever confronted with particular situations where I had a limited shell and there were no means for a quick upgrade. So if I can drop Socat in a box, then it's an easy upgrade, and we'll take a look at that. Now, one more thing I will mention, because I kind of glanced over it, you do need to have Socat on both sides of this. You cannot execute Socat and pass it back to a non-Socat instance and expect it to fully work. I do believe there is a possibility that you may be able to send a Socat reverse shell to like an Ncat handler, and maybe you'll get proper TTY and stuff like that. But to guarantee proper functionality, especially with like the SSL communications and the nice fancy bash features, you're going to need Socat on both sides. So you'll need to drop a Socat binary on your target and have Socat listening on your C2 server. So that's just important to note. But let's take a look at this awesome feature. So here's going to be your big difference. This shell is not going to be encrypted, and we'll actually start a packet capture so we can see that, just to be consistent here. So we'll start that in the background, and here we're doing a TCP listen. So we've got some similar parameters as before, but this TCP listen is the most important thing. So before we were doing an OpenSSL listen, and now we're doing a TCP listen. And what's important about these two things are what parameters we need to specify. So for the TCP listen, we only really need to specify the port. So we'll start our listener, and then we will copy a command I have over here in my notes for the reverse shell connect. So here's where things get a little bit different. So we'll type in our proper port and IP address. So here's our port, and here we have our TCP connect again. Right? Just remember, that's the difference here. This is just a basic TCP connection. It's going to be clear text. And then we're executing a couple different things. We're executing SH, PTY, standard error, set SID, SIGINT, and SANE. I don't really know what SANE is off the top of my head, but the additional feature that we're adding here is SIGINT, which is our signal interrupt. So not only are we passing standard error and bin SH and all that kind of stuff, we also get signal interrupts, which should let us interact with the terminal in a much more native manner. The one thing I'm going to change about this, though, is bash. We're going to send bash over instead of just bin.sh, so that way we get the full bash prompt just like we have over here. If not, it would just give us just a basic sh prompt. We'd still get all the nice features. It'd still be a TTY, and we'd still be able to do things like a normal shell, and it'd still be awesome, but we want the full experience, right? So we'll send this over now, and just like that, we've got a nice bash prompt. So we can do things. We can sue, which you normally shouldn't be able to do. So I'll switch user to root and exit out of that and run a couple more commands and exit. Now again, this particular method was sent over an unencrypted communication. So I just want to demonstrate the differences between that covert channel and that non-covert channel. So we'll follow a TCP stream here. And we can see, of course, everything we did was in clear text. So not secure at all, but still a really nice terminal prompt. And in fact, we got pretty much all those features. You can combine everything we just did with the TLS connection, so you can have an encrypted channel with a nice shell. So that is the power of Socat. And I really think it's probably the best of the tools in terms of feature functionality. But like I said, it's a little bit tougher to find Socat binaries just lying around online. And this can make it particularly difficult to use Socat if you aren't able to install it via package manager on your particular target. And moreover, as a professional in offensive security, you really need to be careful when running binaries that are acquired from unverified sources online. It's very easy for criminals to backdoor or pack malware into a legitimate program. This can even be done in such a way where the normal program will function while silently executing malware in the background. We really don't want to let loose rogue malware on our labs, and especially not on our client systems. So I've put in a bit of work to compile binaries that I can trust from source for Socat for both Windows and Linux, both 64-bit and 32-bit variation. And I even went the extra mile and put out a very small patch to compile a 64-bit macOS binary as well. I would advise you to compile these on your own to practice the same methodology I did, but if you just need a quick and dirty binary to use for Hack in the Box or whatever, feel free to pull a nice, malware-free one from my releases. I'll have GitHub links below. Keep in mind, I did not write Socat, I'm not the author. This is simply a mirror with precompiled binaries that I made for my convenience, and I'm sharing this with the community. So hopefully you find that helpful. Now, Socat is truly very powerful, and it does so much more. However, it's so verbose that I usually just default to Netcat unless I need the power of Socat. However, now that I have these precompiled binaries set up, some of my tactics might change. One final note I'll leave you with is the reverse shell cheat sheet. Now, reverse shells are going to be the primary means of communication for C2 operations throughout the rest of the series. We may still use bind shells from time to time whenever they may become relevant, but for the most part, reverse shells are going to be the most reliable when it comes to actually establishing C2 communications in the real world, and so we're just going to keep demonstrating that here. And in fact, most C2 tools work with reverse shells out of the box, just because it's more reliable when you need to get out of a client environment because firewalls exist. And we'll talk about that a little bit more as we dive into specific types of C2s in the series that deal with firewall evasion and different network evasion techniques. But for now, I just want you all to understand that reverse shells are going to be the primary method of, tossing shells back to our C2 server for this video series. With that, there are several reverse shell cheat sheets, and one in particular that I'll link is the Pentest Monkey cheat sheet. This one tends to be my go-to, but almost any of the ones that I'll link below are just tricks that you can use to send over reverse shells that can be caught by any Netcat, Ncat, or Socat listener for basic C2 operations. Now, this series isn't really about reverse shells so much as it is C2s, but I did feel like sharing this particular resource was important, as we won't be covering the various methods of sending shells in this series. Some of these can even be chained together with OpenSSL to create covert channels for encrypted communications. So that said, I'll leave a link to the Pentest Monkey cheat sheet along with a few others in the description below. As always, I encourage you to explore more, Google, and read your Linux man pages to learn more about what all these tools do. Whether you go with Netcat, Ncat, or Socat, they are all fantastic options with different use cases and features. And if all you need to do is catch a simple shell for basic C2 type operations, any of them can handle that task. Like we saw in the last video, tools like Netcat, Ncat, and Socat are usually best at handling one system at a time. And they're very bare bones when it comes to the broader world of C2s. In our next video, we will dive more into the Metasploit framework as a C2, but until then, I hope you all learned something from this video. Make sure you click like and subscribe to the channel if you enjoyed it, and enable notifications if you want to be alerted when the next video drops. Otherwise, I'll catch you on the next video. Thanks.